Hi, this is Nathan Tintle. In this Learning Goal video, we're going to discuss that margin of error does not protect against non-random errors. We will discuss the controversial Bradley effect example to talk about this learning goal. The key idea here is this. Non-random, or what people call systematic errors, are not what is being accounted for when we compute confidence intervals or tests of significance. The error there is really the variability that's being accounted for in the chance process. So for example, the null model. Let's see this in context. In the USA Today poll, 41% of 778 individuals in the poll said they would vote for Obama. If you put a 95% confidence interval on that value, you get 41% plus or minus 3.5%. Now, in the subsequent primary election, 36.45% of voters in the primary actually voted for Obama. If you test the actual statistic, 41%, against the true value of the proportion of voters on primary day who voted for Obama, which is 36%, you get a p-value of 0.0084. You'll see that that null value of 36% is not in the 95% confidence interval. The margin of error here, the 3.5%, or what we're saying when we get that small p-value, is we're saying, hey, that's beyond what should happen just by random chance. So then the question becomes, well, why did this happen? And in this case, we can point to the four major assumptions of this model, because that null hypothesis test was a model, made some assumptions that may or may not match reality. Here's four things that a follow-up analysis by professional survey researchers pointed to as potential reasons why there was such a difference between what polls were saying a couple of days before the primary and what actually happened in the primary. First, that some people changed their opinion last minute. Second, that people in favor of Clinton were more likely to be non-respondents. So in particular, union households, households with less than a college education were less likely to participate in the poll than they were to actually vote in the primary. Third, social desirability bias. Black interviewers had substantially more Obama responses than white interviewers, even though the interviewers were randomly assigned to which people they would talk to. And finally, since Clinton's name was listed before Obama's on every ballot, the follow-up analysis suggested that some people may have voted for Clinton even though they meant to vote for Obama. A couple of concluding words of caution. Tests of significance and confidence intervals, the margin of error, involve chance models. No model is ever a completely accurate representation of reality. The margin of error, the null model variability, the confidence intervals cannot account for those differences. So should we dismiss all statistics? No, the models can be useful even though they're all wrong. We just need to have a good sense of what the assumptions are. Essentially, what are the limitations of the conclusions that we can draw?